Hi everyone, now we're talking about area under a curve. And so the first thing to consider is why we would want to find the area. And so we're given a graph, and we're graphing speed over time. Okay, we're graphing speed over time. So my y-axis here is speed, and my x-axis is my time. And if we wanted to find distance, well, we know that distance is rate times time. All right, or in this case, we could substitute the r for speed. And so again, if I wanted to find my distance, which as we know, like velocity is the derivative of distance, so I'm kind of going backwards this time. If I want to find my distance, I have to multiply my rate times my time. And so as I go to my graph here, if you can visualize this, my rate's here and my time is here, and so my distance is going to be some product between my y values and my x values, and if I multiply those together, I get an area. And so that's why I want to do that in the first place. Okay, so the first thing we're asked to do is find what's called a left Riemann sum. And how we do this is we use the leftmost point as the height of my rectangle. So I'm just going to make a bunch of rectangles here, and I'm going to make my rectangles between each corresponding x value. So I'm going to make a rectangle between 0 and 3. So between 0 and 3, I'm going to make a rectangle. Now, so that's my width, and so I need to choose a height, and my height is going to be the left point. So I'm going to use 30 as my height between 0 and 3. Right, so here I have a rectangle. Same thing for the next one. I'm going to make a rectangle between 3 and 6, and I'm going to use the left point for my height. So I'm going to use 37 for the height of this rectangle. And then so on and so forth. And so I end up needing to find these 4 areas. And notice which one I left off. I didn't use this 65 here. I didn't use the rightmost point. I'm only using the left points. Okay, so I just need to find these areas. So I just multiply, find the area of a rectangle. So my first height is 30, and the width is 3. And in this case, the width of all of my rectangles is going to be consistent. Okay, it stays 3. Okay, and so if you multiply and add all these together, you get 498. All right, so again, this is my distance. I ended up traveling 498 feet using the leftmost points. All right, now they want me on the next part to find the right Riemann sum. Okay, so very similar process, except this time instead of using the leftmost points, I'm going to use the rightmost points. So when I make my first rectangle between 0 and 3, instead of using 30 as my height, I'm going to use 37 as my height. Okay, I'm going to use the right point. So between 0 and 3, I have a rectangle with a height of 37. Right, and then same thing here between 3 and 6, I'm going to use the rightmost point, so 45. And then 54. And then 65. Right, so notice which one got left off this time. I didn't use the leftmost point. I didn't use 30 as the height of any of my rectangles. And so I should get a bigger estimate here. And so same thing. So if I move on down to part C, it's the same idea. Now this time I know that the width of each of my rectangles is 3, so I'm just going to write that out to the side. And I'm just going to add all my heights together. So 37, and then 45, 54, and then 65. Right, and if I add all those together, I get 603. Okay, so last one, they want me to find the midpoint this time. Okay, so kind of depending on the information that you have, you might have to do a different process for midpoint, but in this case, it's pretty easy. So I'm just going to erase some of this stuff. So literally, I'm just going to pick the middle points. Okay, so I see that I can split my interval into two pieces pretty easily. Okay, so I have one here, and then using the same point, I have another interval that I can pick here. And so between 0 and 6, I can use 3 as my midpoint. And then between 6 and 12, I can use 9 as my midpoint. And so now I'm just finding the area of these two larger rectangles. Okay, so let's move down. And so this time, the width of each of my rectangles is going to be 6. And then the height of my first rectangle is 37, that's my middle. The height of my second rectangle is 54, that's my middle. Right, and so I can multiply those together, and I get 546. So notice the kind of numbers we got. For my left Riemann sum, I got a very low number. For the right, I got a very high number. For the midpoint, I got something right about in the middle. You can probably guess which one is the best estimate. It's going to be the midpoint one's probably going to be the best estimate. All right, now let's do the same process, but this time I'm not given a table, I have a function. All right, so it's the same process. Here, they want me to make 4 equal subintervals between 0 and 2 with this given function. So I know what this looks like. Okay. I know what this looks like. It is a parabola shifted up 1. And they want me to go from 0 to 2. So I'll split it like this. They want 4 equal subintervals. And so I can just use my brain to figure out how wide each of these is going to be. It's going to be 1/2. Or you can use a formula. It's b minus a over n. In this case, b and a are 0 and 2. So 2 minus 0. N is 4, they told me. So I get that each of them is 1/2. Whatever way works for you. This way works great when you have kind of weird numbers. But for now, it's going to be pretty easy. It'll be like this. Okay, so here's my picture. And so first they want me to find a left Riemann sum. So between 0 and 5, I'm going to use the leftmost point, make my rectangle. Between 0.5 and 1, I'm going to use the leftmost point, make my rectangle, and then so on. Okay, and I don't use the y value at 2. Okay, so I know that my delta x, or my width of my rectangle, is going to be 1/2 for each rectangle. Now I need to figure out my heights, and the way I can get my heights is to just find the y values. So I'm going to plug these x values into my function and get the y values. Alright, so the first one is obviously 1. My y-intercept is 1. And then if I plug 0.5 in, I get 1.25. Okay, if I plug 1 in, I just get 2. And if I plug 1.5 in, I get 3.25. Okay, you add all that stuff together, you get 3.75. Alright, next example. And so same picture. 1 and 2. And I'm at 1. Okay, this time they want me to find a right Riemann sum. I'll fill these in too. Okay, so between 0 and 0.5, I'm going to use the rightmost point. And then kind of so on. Okay, so notice this time on my graph, you can pretty clearly tell that I'm above the function. So I have these areas that I'm finding. Whereas over here, on my left Riemann sum, I was below the function. So look at these gaps that I have. Look at these overestimates that I have here. Okay, so that should kind of give you an indication of if this is going to be an under or an overestimate of the actual area under the curve. All right, you can see this is going to be an overestimate because I have this extra area here. Whereas over here, underestimate because I have these gaps. Look at these gaps here. Okay, so I want to find a right Riemann sum. So again, the width of each of my rectangles is 0.5. And then I'm just going to reuse some of these y values I already found. And then I just have to plug in 2 to my function. So 2 squared plus 1 is 5. and you add all that up, you get 5.75. Okay, so again, underestimate, this looks like it's going to be an overestimate, it's much bigger. Okay, so let's move on to midpoint. Okay, so I draw the same picture, my curve. Okay, and this time I'm choosing my heights based on the midpoint. So between 0 and 0.5, I have a midpoint of 1/4, and so that's where my rectangle comes into play. Here my midpoint's at 3/4, here it's at 1.25, and then here it's at 1.75. Okay, and you'll kind of see that these areas that I'm finding, there's a little bit of the area of the rectangle above the curve, like right here, and there's a little bit under the curve, and those should sort of even out and give us a better estimate of the overall area. All right, so I'm just going to write out my work. So again, I know that the width of my rectangle is 1/2. Okay, so for my first rectangle, the height, I'm evaluating it at 1/4. That's the midpoint between 0 and 0.5. So it's 1/4 squared plus 1. Okay, I'm plugging this into my function. Okay, my next height is also 1/2. My next midpoint is 0.75, or 3/4. Okay, my next rectangle also has a width of 1/2, and so the midpoint between 1 and 1.5 is 1.25, or I could say 5/4. My next width is also 1/2, and the midpoint between 1.5 and 2 is 1 and 3/4, or 7/4. All right, and so these are all my midpoints, and if I add all those together, I get 4.625. Okay, so last example, we're going to do pretty much the same thing. So this time we have a table, and they give me an initial condition. They say that the tank contains 150 gallons of water at time 0. So that's the only difference, really. And so they want me to estimate the amount of water I have after 12 hours using a left Riemann sum. So again, I just use my delta x's. So between 0 and 5, I have a width of 5, and I'm using the left point, so 8. Between 5 and 8, my width is 3, and I'm using the left point, so 8.8. Between 8 and 12, I'm using the left point, I have a width of 4. Okay, so if you add those together, you get 103.6. And remember that I had 150 gallons of water initially. So I have 253.6 gallons of water. All right, so same deal here. I want to estimate the amount of water I have using a right Riemann sum. So my widths are going to stay the same, except between 0 and 5, I'm going to use the right point. So 8.8. And then 9.3. And then 9.2. Right, so if you add all this together, you get 108.7. And again, I had 150 gallons to start with, so I get 258.7 gallons. All right, so this time pretty close, but chances are this is going to be an under and this is going to be an overestimate because of an increasing function, but we can't really know for sure. All right, so that's it for this video. I'll see you all later.